Welcome to this tutorial on the Serial UART mp3 and WAV player, or wave player. Who knows how that's supposed to be pronounced. Anyway, as you can see by the picture on the screen, these are a very small board. They're supposed to be able to play mp3 and WAV files. I've no idea about the mp3 files because all of my files that I've used are WAV files. Little tip about using these just before we start: the files go onto an SD card that fits into the back of the board. That's the only way you can get your files in there. I would advise you to use a program something like Audacity, which is a free download. There's a link in the Digital Town website on the link at the bottom of the page, and it'll be below the video, but it's a free download and it enables you to reduce your file both in size, and obviously you can reduce it to a mono file from a stereo file if you need to, because if you look on the board you'll see in the top left corner you've got the speaker output and there's only one speaker, so it only plays in mono, and the same for the headphone jack. Just on the subject of the headphone jack, I've noticed that some of these boards come with a headphone jack, some don't, so keep an eye out when you're buying them. They seem to be the same price whether they come with or without, and these boards you should be looking to pay sort of £3 to £4 on somewhere like eBay. Now they connect to the serial port, and what I'm going to do now is quickly go over and show you how the circuit is built. Again, all the wiring will be in the top of the sketches. It's a very simple circuit. Obviously you've got a ground and a VCC which you can put 5 volts in, and then you've got a TX and an RX. Now because I'm using an UNO, I only have the one serial port, but obviously I'm using that when I'm using the serial monitor. So in the examples that I'm using today, I will be using the software serial library, and for that I'll be using pins 3 and 4. So that's the basic circuit. I'm just trying to think, is there anything else I need to mention before we get started? Yes, one other thing. When you are putting your files onto the SD card, one of the things I've noticed with this module, and I've had the same with the DF Mini player, is that they don't seem to be able to cope very well with any fragmentation of the files. It's almost as if they're pushing themselves to the limit. So what I tend to do is format the entire card and then put all of my files on in one go so that there is no fragmentation in there. One of the other things is there is an ability to put files into folders. I tend to put all my files in the root directory because I'm using this just to play sounds on a model railway. I'm not trying to build a mini player or something like that, so I'm just playing random sounds as and when I want. But there's a particular function that I use where you can play a file with sound, which doesn't seem to be available to play that file with sound from a folder. So I've tended to put all the files in the root directory, and that's what I'm assuming for this tutorial. So let's have a look at how this works. Now before we start looking at how to program these, this is the manual. I've put a link to it on the Digital Town website, and as we go through this, obviously picture of the boards, what the board is capable of doing, and as we go down, I'm going to miss all the circuitry. These are the important bits. These are the commands that we actually send to the board, and we will be looking at these as we go through the examples. So what I'm going to do now is get the IDE started and we'll have a look at the code. Okay, so here we are looking at the code. As you can see, I've got the manual up on the right hand side because we're going to be referring to the manual quite a few times. The reason we're going to look at the manual is I could have just put some functions up here and just made the thing work, but I'm actually going to explain how the actual system works, because then if you want to build your own functions you'll know what you're doing. So obviously I'm including the software serial library. I'm using pins 4, pin 3 as I said. I'm starting software serial and my instance is called my mp3. Obviously it takes the pins as values that go to that. That's how software serial works. So in the setup I'm starting the normal serial monitor output, and I start our instance of software serial. It begins at a baud rate of 9600, which is what the board requires. Then what I do is we have a half-second delay. This is just to let everything settle down. Some of the things I've noticed about this card, and you'll see it now and again, I've got some delays in a few little places. If you seem to send one instruction straight after the other, you can have a bit of a problem. So anyway, let's get started. So the first thing the manual says you need to do is select the TF card. I must admit I found this a little bit amusing, because the only way you can have sounds on this board is via the TF card, so why they don't have it active by default is beyond me. But anyway, you have to send a set of instructions, and obviously the instructions are in here. Where are we? We've got to where on earth am I on here? There we go. Select the storage device, and the code is 7E033501EF. Now if you're new at programming, those are in hexadecimal, and if you don't know quite what hexadecimal is, if you take your calculator, if you're using something like Windows, put it in programmer mode, and if you put in the value, I go to hex and put in 7E, you'll say it has a decimal value of 126. But we're using hex codes because hex codes are what the instruction manual uses, so it keeps it easier. Now the hex code, to show that it is a hex code, you put a 0 and then a small x before the value that you're putting in. So our first instruction that we've got to do is we've got to select the TF card, and this is the code that we're putting in. So with each instruction, if you look at the manual, everything starts with 7E and everything ends with EF. That is because 7E is, if you like, the first byte that's sent through that says to the unit, this is the beginning of a new instruction, and EF tells the board that that is the last part of the instruction that's coming through. The next value that's sent, in this case, is 3, and that's the number of instructions that are being sent, including this value. So if we look at this, we've got value 1, value 2, value 3, and then we've got the end and the beginning. This value that's sent excludes the start and the end byte. So 35 is our command, and in this case the data is 1. I assume that means that it's selecting something like card 1, even though you can only have one card. But anyway, that's the instruction, that's what we do, and that then connects to the SD card with our sounds on it. I then do a delay for 20 milliseconds. It's not long, but it just allows the board to sort of set everything up. Now when you want to play a song, and this is why you'll see later that I've written some functions to make this easier, if you want to play the first song according to the manual, you put in the code 7E, our beginning byte, 04 because we're going to send 4 bytes, 41 says we're playing something, 00 is the directory, which because I put mine in the root means it is 0, and I'm going to play the first song. Now if you notice down here, this is one with a folder, so it's this time they've given an instruction of 42 because you're playing from a folder 0101, so it's the first track in folder 1. That's why I just leave them all in the root, it becomes easier. Anyway, let's look at the code that we're sending. So that's the code here. So we'll see 7E, 4 bytes, instruction number 41, And then we've got a problem because we send a value of 0. Now when you try to compile with just a value of 0x00, you get an error. You actually need to put byte in here to force it into a byte format. Thankfully, in the later examples I'll show you I've got round that. Then of course we send our 0, 1, and then we send our end of signal, end of code. The sound will then play. I've done a delay for 3 seconds just to allow the sound to do its thing. And then what I've decided to do is play a second sound. It does exactly the same thing, except this time I'm playing sound number 3. Now I apologize in advance for the sounds that I'm about to play you. I think one is a grinder and the other is a arc welder, because obviously I'm building stuff for a model railway workshop. So as you can see, my sounds are not likely to make the top 10 of hits this week, and as you've seen from what we've written, this is not the easiest way to send instructions to a board. So in the next sketch we're going to look at a way to simplify this, making it far more logical to do. So this is the second sketch, and before we start, obviously software serial starts just as it did before. The only thing that I've done at the beginning is I've created an array called send buffer. It's a byte array, and the good thing about having a byte array is, if you remember in the previous sketch where I had to force a value to be a byte, now because I'm putting that value into a byte array, it is guaranteed to be a byte, so it gets rid of a particular problem. Now previously, if you remember, the first thing we had to do in the setup, we began our serial, then I started the software serial, had a delay of half a second, and then we had a load of codes that we passed, and it is this one here, 7E033501EF. What I've done now is I've created a function called select TF card, and it calls this function, and if we go up to the top here, all the function does is put all the values that are in the particular code. There we go, there's the codes we want there. I've written them out again here. So it puts these values into the array. It's putting it into the first 5 elements of the array, and then it sends, then calls a second function called send UART command. And if we go down to this, all that function does is it works through the buffer, sending out each part of the buffer one item at a time, and it sends, the number of items it sends is send buffer 1. Do you remember we've got the first item was the number of bytes excluding the beginning and the end, so we've got 3 plus 2 others. So in the function it looks for the value of the first the length in the buffer, and it then adds a value of 2. So if I pass 3 data parts, it knows add the front and the end, so there's 5 plus 2, so it sends all of those items out. And then what I've done is I've printed it out to the serial monitor just so that I could see what happens. Obviously you can comment that out in a working version, and then I've put a delay in of 25 microseconds, and again I've messed around a little bit more, found a couple of odd things that putting this delay in seems to prevent. So that's all we do in the setup, is we select the card and then we drop down to the loop. Now I've declared a local integer of Q because I'm going to use it a lot, and we're going to start to play sounds. And what we're going to do is we're going to call a function play sound, then I'm going to have a delay for 4 seconds, then I'm going to call a function called stop sound. So let's have a quick look at play sound. So play sound takes the values, and you see this, it's in the thing play with index. So it's playing sounds within the root directory. So there's our start byte. We're going to send 4 bits of data. Sorry, 4 bytes of data. So that's the instruction for what it's going to do. It's telling it that there's no directory, and then it's going to send the song number or the track number, and then the closing byte, and then obviously it sends it to be sent out. So what I'm going to do is it works through 5 different tracks. I apologize again for the tracks, but that's all I've got because they're all workshop sounds. So as I play this, and again I apologize for the quality because I'm actually holding this up to the microphone, but you'll hear it work through the different sounds. So from that little example, you can see that by changing the value of Q with the function play sound, you can work your way through the different sounds on your card. One of the annoying things about these units is obviously you can't put in the file name. So what I tend to do is put all of my sounds on the card, and then I write a function like this that works through all of the sounds, and then I write down what each sound does so I know for my own reference later on. So moving on from that, we've then got the next function, and this is set play volume, because those sounds that were playing first time round were just playing at a default volume. I never set it, that just seems to be what it came with. But if you look in the manual, there is a ability to set the volume, and the volume is set by this data bit here, 0f, which 0f is 15. So if I now go up to my functions, I've got play sound, stop sound, where are we? Set play volume. So here we go. There's the code that we're going to send. We've then, so I send the start byte, 3 bits of data. This is the instruction, which is actually telling the unit change the volume, and then I'm sending the value of the volume, and then of course it'll put the end byte in. So what I do is I work through the loop, the for loop. It plays the sound for a couple of seconds, and each time it changes the volume. Now I've got this thing running in the background, and I'll just try lifting this up to my speaker and see if you can hear the thing. So it starts very quietly. And then slowly my electric drill sound is increasing in volume. Well, hopefully you've got the idea of how that works, and there's no need to torture ourselves anymore. So I'm just going to comment this out, so decomment this and comment this here, and we'll go down to the last function that I've created. This time it's play sound at volume. Now the reason I created this is being able to change the volume's great, being able to play a sound is great, but for something like the project that I'm working on, what I really want to be able to do, rather than trying to mess around in programs like Audacity trying to get all the sounds right, I would like the ability to play my sounds at different volumes. So what this does is it uses a function here, play with volume, that not only sends the instruction as to which track to play, but also what volume to play it at. So we've got play sound at volume. What I'm doing is I'm always playing track 4, but I'm changing the volume each time I play it, and I'm actually incrementing this time in values of 10. So if we go up to the function for this, we've got obviously start byte. This time we're sending 4 bytes of data, an instruction to play, a piece of data that tells it the volume that it's playing at, a piece of data that tells it which track it's playing at, and the end byte. So the idea is that in my project, this will be the main function I will use. So I will play a sound at a particular volume, and then I'll probably call stop sound just in case, because I don't want that particular track to overrun if something else is happening. Although a lot of the time I won't call stop sound, it'll just run out naturally. So I'm just going to upload this and I'll play you the example and torture your ears again. So this time it's jumping in much bigger steps. So that's enough of that noise, but now you have basically 5 functions that will help you, especially if you're doing a model railway project. So you can start your card, select your card, you can now play a sound, you can stop a sound, you can set the play volume, and you can also play a sound at a volume. Now what I thought I'd do for a final sketch is put all this together and allow you to see how it would work being controlled by a couple of buttons. So I'm just going to swap some things around and we'll get back to it. So for this next example, we're going to use the circuit that's here. As you can see, I've added 2 buttons. One is connected to pin 8, the other is connected to pin 9. Within the sketch you'll see we're using a debounce. We've got a couple of 1K resistors, I think they are, that go down to ground to stop the pin floating. Again, if you go to the Digital Town website, not only is there all of the circuit diagrams and the sketches, but there's also the resistor values in there in case I've got that wrong. So let's have a look at the code and see how this is going to work. Okay, so this is the final sketch for today, and this is really how you would use this in reality. So I've got 2 buttons that I've defined, button 1, button 2 as creative thinking. I've also got an unsigned long called button debounce because we're going to be using a millis timer to prevent getting multiple button presses, because obviously if your finger holds on the button, you're going to keep sending the same codes through over and over again, and your sound is going to get a little bit weird. All the functions that were used in the last sketch I've left in here, so we don't need to go through them. So the big difference is obviously everything down to here is the same. The big difference is now is button 1 and button 2. I've set a pin mode as inputs because they're buttons. Going down to the main loop, I've got an integer, a local integer called button pressed. Here is the millis timer. So if the number of milliseconds since the board started is greater than the value of button debounce, which is an unsigned long because these numbers get very big, then it will run through this circuit. So if we can imagine nothing's been pressed, we're ready to go, it checks the first button. It says, right, has button 1 been pressed? If button 1's value is greater than 0, which means it's been pressed, The first thing it's going to do is it's going to reset the debounce timer for the button press. It's going to add 0.2 of a second. Then what it's going to do is it's going to stop any existing sound that's playing, because I could have already got a sound playing. And then what it's going to do is it's going to play track 1 at a volume of 15. I think it's my electric drill according to my notes. Now then what you'll see is I've got another function using a millis timer again. It's using it's checking against button debounce, because obviously if I've just pressed button 1, I don't want it instantly to start picking up button 2. So what it does is it repeats exactly the same process, except this time it reads button 2, and this time if a button is pressed, it plays track 3, which is my arc welder, at a volume of 25. So let's give it a go. Let's press one button here. There's the first item. If I now press the other button, there's my arc welder. Back again to the first one, and I can swap between them at will. So if I was using this on a layout, I could either have these sounds triggered off buttons, as I've done in this, or as I'm going to do on mine, it'll be controlled by a DCC controller, and the sounds will be being controlled by an accessory decoder. So different code values will be sent depending on which sound I want to play. I've already built the control panel for this, and there'll be a separate article on the Digital Town website showing how I put the whole thing together. But so on that example, instead of using a button, it's going to be reading a signal that's sent from a DCC++ base station. So I think that's just about everything today. I'm just going to bring over one last sketch onto the screen. This one is again on the Digital Town website, and it was the sketch that was written by the guys, I think, who basically wrote the board or created the board. You'll see that it was written in a very different way, and if I scroll down, you'll get, where are we? Yeah, this is the way I was using it before, and you had to call this function play with volume and then pass the various codes. And I'll be honest, I just wanted a simple function, and this is why I rewrote this. So full credit to the guys who created this. It works fine, but I just found for someone like myself who just wanted to pass a value of the next track to be played with a volume, I found an easier way, and that's why I wrote it the way I did. However, I have put this sketch in the additional sort of resources at the bottom of the page on the Digital Town website that goes with this video, along with the manual, so everything is there for you. So hopefully that's given you a bit of an understanding of how these units work. I think they're a very useful item for model railways. I've found them very, very good. I've got some that I've then coordinated with, as you can tell, if you can hear the arc welder, you can imagine I'm also triggering a LED that flashes alongside it. I've done some hydraulic sounds that sound at the same time as I've got a lift bridge that goes up. You can do all sorts of things. You know, if you had the sound of someone shoveling coal when the loco goes into the coaling station, you could actually press the button and it'll sound like the thing's filling with coal, or you could do the same with water. So a very simple unit to use, very simple to wire up, and you can either plug it in through the speaker, or you could even plug a speaker in to the headphone socket if you want to make your wiring even easier. So I hope you found that useful, and if you did, you know, please press the like and subscribe. Bye for now.